Hi everyone, thanks for joining us. I'm Somaieh, the stream owner for AI Ethics at ACE. ACE is a global community of machine learning enthusiasts and practitioners founded in Toronto, Canada. We are currently working on creating a repository of YouTube videos that showcase authors talking about their research. Because with all the machine learning research that comes out every day, it is hard to figure out what to pay attention to. And our hope at ACE is to make that a bit easier by highlighting the work that we think is important. We also host social events where you get a chance to network with community members, and we host workshops that teaches you to translate machine learning to code and real-world application. So today we are joined by Ben Green. He's going to talk about an algorithm in the loop analysis of fairness in risk assessment. So Ben is an assistant professor in University of Michigan School of Public Policy and a postdoctoral scholar in Michigan Society of Fellows. He holds a PhD in applied mathematics with a secondary field in science, technology, and society from Harvard University. Ben studies the social and political impacts of government algorithm with a focus on algorithmic fairness, smart cities, and the criminal justice system. His book, The Smart Enough City, Putting Technology in Its Place to Reclaim Our Urban Future, was published in 2019 by MIT Press. Ben is also an affiliate at the Berkman Klein Center for Internet and Society at Harvard University. I'm so excited about this session and I'm looking forward to the talk, and I hope you are too. So first, Ben is going to make his presentation uninterrupted, and then we have discussion for the remainder of the session. So feel free to add any questions you have in the live chat, and I'll make sure to relate them to Ben as we discuss. So Ben, the microphone is yours.
All right, great. Thanks so much for the intro, and thanks everyone for tuning in. I'm going to share my slides and I'll talk for about 25, 30 minutes, and then we can open it up for discussion. So my work that I'm going to describe today is sort of a line of work of a couple different papers, all joint with Yiling Chen at Harvard Computer Science on what I call an algorithm in the loop analysis of risk assessments. So this is really a broad talk that brings together some work I've been doing for a couple years, really 3 different papers on this topic, and sort of summarizing what they are all saying and where this leads us into the future. So the focus of this talk, just as a little bit of contextual background, is on the use of risk assessments in the criminal justice system. This is really a notable example of machine learning tools that are being implemented into public policy, particularly into the settings of pretrial or bail decision-making, sentencing, and parole. And what these risk assessments do is they provide predictions of someone's likelihood to commit a crime in the future or to be arrested, really, is what's actually measured. So various measures of arrest in the future, and in certain settings, whether that person will fail to appear in court in the future, particularly in the pretrial setting. And these algorithms have seen a really rapid rise in the United States, and other countries as well, have increased a lot in terms of how many jurisdictions are using them, and have achieved really broad bipartisan appeal with both Democrats and Republicans and reformers and a lot of different groups wanting to use these tools. The theory of change, of sort of what's the value of these tools, is in really 2 different things. The first is objectivity, that risk assessments will mitigate biases by making objective decisions, replacing human biased decisions with objective, statistic-based, algorithmic ones, and that in doing so, these risk assessments can provide one type of criminal justice reform, replacing discriminatory policies and reducing incarceration. So there's been a lot of discussion about these risk assessments, and there's a lot to say on questions of fairness, of how these risk assessments actually operate, the quality of the data, the quality of predictions, the various questions of justice of whether and how these algorithms should actually be used at all. But what I want to focus on in this talk, and what I focus on in this research, is the question of how risk assessments actually affect decision-making in practice. A lot of the discussion around risk assessments, both positive and negative accounts of these systems, really focuses on how the algorithms make decisions themselves, sort of the quality of the data and the predictions and how this technical system operates. And the question I want to look at here is, when you actually put these algorithms into practice, how do they affect outcomes in public policy? What are the actual human and algorithm interactions that play out in practice, even beyond whatever specific predictions a risk assessment might produce? So the key sort of conceptual approach to this work is to really place risk assessments within the context of criminal justice decision-making processes. So typically in computer science and other ways of approaching these systems, we really think of it as this fully defined independent entity, that we have a risk assessment and that algorithm makes a decision on its own. And what we then need to analyze are the nature of those predictions or decisions. In reality, of course, what actually happens is that these algorithms present information to a judge or other officer, and then that person has to make the final decision. And so really what the risk assessment is doing is providing an additional piece of information alongside other sources of data and information and context about any one particular case or defendant. And then the judge has to decide, okay, how do they actually make a decision in light of that? So we can think about this in relation to a common paradigm in algorithm development, where, again, so we typically think about algorithms as making these final decisions. And sometimes, though, we'll talk about how humans are involved in the process, but it's really about humans being used to train or refine the algorithm. And that's what might be more familiar with as human in the loop systems, that humans are being used to help algorithms make decisions in various ways. But ultimately, what we're caring about is how the algorithm operates in practice. But this, as I was just describing, doesn't actually match the reality of many public policy settings where algorithms are being used, where criminal justice is just one of those. So what we actually have are settings where we have people who are civil servants of various sorts who make decisions. And what we're increasingly doing is implementing or integrating algorithms into that human decision-making process. So what I describe this as, in contrast to a human in the loop setting, is an algorithm in the loop setting, where we have a human decision-making setting and we're increasingly integrating algorithms into that setting as a way to help the humans make those decisions. And so this opens up this new frame of analysis, allowing us to look not just at the algorithm in isolation, but to really look at how the algorithm affects human behaviors and treating it as part of a larger socio-technical system where we have now all of these different components that are working together to create decisions. So I'll talk about two different sets of studies. The first, which brings together the first two of the three papers, is really, and these are really focused on how people interact with risk assessments when making predictions. How people, how does being shown and using a risk assessment actually affect how people are treating these types of information? And in particular, we wanted to look at whether people adhere to various values that are central to procedural justice and other forms of sort of normative theories around decision-making, of accuracy, reliability, and fairness. And we built out an experimental method for testing these questions. But just as a really high-level sort of preview, what we did was, in an experimental setting, have two different groups. One is a control group, one is a treatment group, where we can test the effect of introducing risk assessments into human decision-making processes, where in the control group, we can have people making predictions about specific cases without a risk assessment. And in the treatment group, we can have people making those same exact predictions, but with the aid of a risk assessment. So for background, a couple areas of related work that are particularly important for how we approached this study and some of the hypotheses that we had. The first thing is that a number of different lines of work show that people struggle to interpret and use algorithms when making decisions. People often discount algorithmic recommendations and are quicker to abandon an algorithm than another person after seeing that agent making mistakes. But also people respond to information and algorithms in unexpected ways. Various types of policies, not even necessarily related to algorithms, that attempt to either provide or remove information that might lead to biases can actually have unexpected impacts based on how people interpret the new information or the lack of information that is either provided or not provided. And in particular, various more recent research showing that judges often ignore risk assessments or respond to them in biased ways, showing that in practice, many of the effects of introducing these systems into decision-making are not what might be expected just from looking at the algorithm itself, further demonstrating why this type of algorithm in the loop approach is necessary, because what happens in practice is actually quite different from what might happen if the algorithm were operating on its own. So we looked at 3 hypotheses here based on these different principles. The first being accuracy, that you would want to increase accuracy, but we imagine that people presented with the risk assessment will make predictions that are less accurate than the risk assessments on its own. Number 2 is reliability, that participants will not be able to calibrate their use of the algorithm to account for its accuracy. And third is fairness. Participants will disproportionately penalize Black defendants in their interactions with the risk assessment. So all of these hypotheses really connect to these central principles where what you would want to see is that people are able to work effectively with the algorithm to make more accurate decisions or predictions, that people will be able to provide some sort of oversight over the algorithm, that they could account for whether or not particular predictions are high quality or low quality, and that people will interact with these decisions in ways that are fair with respect to the different types of groups they might be making decisions about. So I'll give an overview of how we designed this study. The first part was to actually develop a risk assessment that we could use in our experiments. So here we worked with data from the Department of Justice, a really large historical data set. We used that to develop a risk assessment using pretty relatively standard machine learning tools to develop predictions of people who were released before trial, whether that person would be arrested or would fail to appear in court before their trial, and then pulled a small sample from that population that we had made predictions about to put into our experiments. The experimental design was, the central part was sort of in the middle here, this prediction task, where we, which I'll describe in more detail in the next slide, but where we would ask people to make predictions about a series of defendants, and then we could analyze what those predictions were. So we got some basic information from participants in an intro survey, had them go through the prediction task, and then finally got some reflections on their task and on their behaviors at the end. And we did this in the context of Amazon Mechanical Turk, which is an online crowdsourcing platform where you can pay workers to complete relatively short-term tasks, and is often used in social science and computer science, sort of human subjects experimental research. And so we had several hundred participants from Mechanical Turk who each made 40 predictions, giving us over 15,000 total predictions that we could analyze to understand what people's behaviors were. So the obvious caveat here is that this experiment is operating, we're not looking at how judges are making decisions in a courtroom, but looking at how lay people are operating in the context of Mechanical Turk. And so on the one hand, this certainly takes away from the realism of the sort of looking at the exact context we want to be looking at, but allows us certain affordances, on the other hand, of being able to create a more controlled experimental setup and create and analyze data in ways that wouldn't be possible in practice. So we can really think of this not as perfectly describing what would happen in practice, but as a valuable diagnostic tool that can help us gain better knowledge about how humans and algorithms are interacting before we put these systems into practice. So far better that we gain preliminary insights from a setting like this, rather than deploying risk assessments or other tools into public policy without really having any idea of how they might actually be used in practice. So, the prediction task, this core element was to get these predictions from participants about defendants. In the control group, so for everyone, what they would see was a defendant profile, so some basic information about the defendant, each defendant that they were asked to be making a prediction about. So for the control group, they would make these predictions just based on this profile. In the treatment group, they would also be shown the risk assessment's prediction about that specific defendant and would be asked to make predictions. So what we can see here is one of the particular benefits of Mechanical Turk is that we can set up this neat control and treatment different groups, and they can actually make decisions about the exact same set of defendants. So we can present the same defendants multiple times to participants with and without the risk assessment to really see exactly how these decisions are, how these predictions are changing from the control group without the algorithm to the treatment group with the algorithm. So I'll summarize the key results that we found according to these three principles that I described. So the first is accuracy, which we looked at the accuracy of each participant predictions. And what we would want to see is that people who are using the algorithm are able to make more accurate predictions than they could if working alone, but also ideally than what the algorithm could do on its own. So what we see are we can look at these three different groups, the control group, the treatment group, and the risk assessment on its own, and compare the performance of the predictions that are made. So what we see just comparing is that there's just going from left to right here, there's a gradual improvement where the treatment group who is shown the risk assessment does outperform the control group. So clearly we're increasing the accuracy of predictions, but interestingly, the treatment group is not able to match the performance of the risk assessment alone. So although there's some improvement, we're not achieving the type of collaboration where the collective of human plus algorithm is actually able to achieve anything better than what either of the two components could achieve on its own. Second principle is reliability. And here, what we really want to look at is, are people able to, when they're incorporating the algorithm into their predictions, are they able to account for the quality of those predictions, where they are able to more heavily rely on high quality predictions and less on low quality predictions? And often this is how oversight of these systems is described in policy and in other policy discussions, where because we may not trust the algorithm completely, we'll say, okay, well, we still have a human making the final decision. As long as that person is making the final decision and doesn't have to follow the algorithm, then we're still getting the types of decision making that we would want. So in this plot here, what you would hope to see is that as the performance of specific predictions improves, the influence of the risk assessment on any given prediction would be higher. So that would be a positive sloped line showing this relationship. What we actually found was a surprisingly negative relationship, where as the performance of predictions improved in various settings, people were actually less likely to rely on that prediction. So people are clearly not acting as a reliable form of quality control that is allowing us to ensure that the high quality predictions will be given more weight and more focus than the low quality predictions. And the final principle that we looked at is fairness, wanting to compare how people respond to the risk assessment, particularly when making decisions about Black defendants and white defendants. And what we looked at were settings where the risk assessment's prediction was higher than the control group's prediction. So effectively, what we're looking at here are settings where the risk assessment would generally be recommending that people increase their estimated risk about defendants, essentially telling them, generally pulling them towards predicting higher levels of risk. And we can compare in those settings, what is the influence of the risk assessment in those particular settings. And what we found was a pretty notable disparity between the influence of the risk assessment in these cases, depending on whether the defendant in question was Black or white, where when defendants were Black, participants effectively took an even average. They weighed the risk assessment prediction as heavily as their own prediction without the risk assessment, whereas when defendants were white, the recommendation to increase their prediction was much more heavily discounted. And so what we see here is a particular, not only just a particular form of bias, but a particular form of bias that only becomes visible if looking at if taking a particular algorithm in the loop approach, because this is happening above and beyond whatever fairness or bias there may be in the predictions themselves. This is showing that the predictions that are made as people interact with these predictions can exacerbate racial biases because they're more likely to rely on the predictions and to be influenced by the predictions in these particular ways. So what we found in these two studies is a variety of breakdowns in human algorithm collaborations for making predictions in policy relevant contexts. So there was some improvement in accuracy, although we're still seeing that the human and the algorithm are not still particularly well collaborating together, even in terms of accuracy. And more importantly, the reliability and the fairness principles that should be quite central to any theory of just decision making were not satisfied. So what we see is a significant gap between the predictions the algorithm may be making and how people are actually utilizing those predictions, suggesting, again, a number of breakdowns in how people are making predictions with algorithms that suggest significant issues in our ability to necessarily get out of algorithms the types of objectivity and sort of reliable and fair decision making that we might want. So this really leads into the final study, the third paper, which I won't spend too much time on just so that we can have more time for Q&A, but I'll sort of just give a high level overview of what this paper was about, where we really shifted here from how does the risk assessment affect people's predictions to how does the risk assessment actually affect human decision-making processes? Because in practice, what you have is a judge is not making a prediction of this defendant has 30% risk, for instance. What they're really doing is deciding, do I, in the pretrial context at least, do I release this defendant or do I detain this defendant until their trial? So here, what we looked at was adding in the prior study where we had some people were shown or not shown the risk assessment, and then we had people who were making predictions. Here, we were taking that one step further into thinking about decisions and asking people, for the most part, to make a more binary decision of releasing or detaining a defendant rather than, again, a quantitative prediction from 0% risk to 100% risk. So I'll skip through some of the sort of specific setup and all of that just to highlight what we really found here was what we really found in this study was that the risk assessment is actually shifting how decisions are made as a function of risk. So if we look just at this, the plot on the right is the comparison between the control and treatment group in how their likelihood of making a decision to detain someone based on their perception of how much risk of being arrested or of failing to appear in court that defendant has. And what we're seeing here is that these two curves, the blue curve is the control group and the yellow curve is the treatment group. These two curves are actually different. So being shown the risk assessment doesn't just influence how someone doesn't just influence someone's prediction of risk about a defendant. It actually shifts how people are weighing risk or preventing risk in their decisions and are ultimately placing a greater emphasis on risk, where in the treatment group, people who are lower risk have a lower likelihood to be released, and people in the people who are higher risk have a higher risk of being detained. And so the treatment group who are shown the risk assessment are making decisions in a manner that is more reliant on someone's level of risk as a determining factor in how they are making decisions. So to wrap up so that we can have plenty of time for discussion, I want to highlight two broad contributions of this line of work. The first is really highlighting how algorithmic interventions are highly indeterminate as forms of affecting public policy. We often assume that we can implement the algorithm can make decisions that are, have these characteristics, have these qualities, may improve on human predictions or decisions in these ways. But that's actually not how it works in practice, because the algorithm doesn't operate in a vacuum. We need to look at how the algorithm actually interacts with the other people and the social context to better understand what its impacts are likely to have. And that's what these studies are really focused on. So in the first study, what we found in particular was that predictions that people are making with the aid of a risk assessment can be unreliable and unfair. And in the second study, showing that risk assessments can increase the emphasis on reducing risk that people have when making decisions. And this is actually akin to a significant shift in public policy, one that can also have disparate racial effects of a different sort than what we found in the first study. The second and broader contribution here is providing a type of experimental framework for developing and evaluating algorithms that are going to be put into human decision-making contexts, particularly in public policy. And so given the indeterminacy that I was describing, we really need to understand these effects before putting algorithms into place, especially when they're going to be affecting life-changing decisions so in the criminal justice system, or affecting welfare determinations or anything like that. And so these types of experimental studies with lay people provides a promising approach for gaining much more rapid-paced preliminary knowledge about these types of interactions, rather than having to wait until we put these systems into practice and not knowing what it's going to do in these high-stakes settings. And this is further justified because a number of experimental studies have shown some alignment between the behaviors that judges exhibit and the behaviors of lay people. And even in this particular context, some of the empirical studies of judges using risk assessments in practice have findings that align pretty closely with the experimental results described here. So this provides a really nice way of gaining a lot of knowledge about how these systems operate, and can also then help to actually provide guidance for what types of policies need to be in place to oversee these systems, how to design the algorithms, and ultimately, of course, the broader questions of whether or not these algorithms are actually should be used at all, And that's something I've done a lot of research on and have other writing on, is why we should be wary of risk assessments more broadly as a tool for criminal justice reform, both including these types of issues that are described here, but also above and beyond that, other issues connecting to the mode of reform that is actually being presented here. But just sort of ending on this, so we can see a lot of ways in which this algorithm in the loop approach can suggest numerous directions for future work, open research questions that really can focus on how do people interact with algorithms, and how can we, in the settings where algorithms are maybe appropriate, how can we improve those types of interactions to attain more accurate, reliable, and fair decision making. So I'll wrap up there. I'll close the slides, and we'll look forward to your questions and comments.
Thank you, Ben. So while I'm waiting for the questions on the chat, so I'll start with my question. So thank you so much. That was an interesting talk. I mean, a lot of discussion over the past couple of years has been focused on how to make this algorithm more fair, but not a lot of studies on what is actually the impact of these algorithms. I mean, even us as human, when we receive an advice, we make a different decision than without having an advice. So, and this is a very good case study and example to show how this algorithm can impact actually the final prediction. So I'm going to first go back a little bit about where you mentioned that to perform this experiment, you already developed a risk assessment tool using some data from Department of Justice. Can you first explain a little bit about the data set that you use, how many variables, how many features it had, and I mean, how did you pick that data set? Why did you pick that data set?
Yeah, so the data set that we used was a really rich and comprehensive data set. It had, either tens or over 100,000 cases between 1990 and 2009 of criminal defendants across the United States, and really had information about them going through the entire process. And so what we were looking for broadly was a data set that we could find so that we could develop a pretrial risk assessment just for use in our experiments themselves, that could align with the types, so that it could look like the types of risk assessments that are used in practice to better match reality in our experimental settings. And so this data set has been used in other studies as well in this type of setting. And it can be really hard to get this type of criminal justice data for all sorts of privacy and data sharing reasons. This one is managed through a data sharing repository, social science data repository, and so was much more readily accessible through going through a data sharing process. But what it has is a lot of information, many different defendants, but has information about their both their who they are, their criminal background, and also the evolution of their case. Because what we ultimately needed was to know, of people who are released before trial, what ends up happening. How many of them are arrested or not arrested? How many of them appear in court or do not appear in court? Because that's ultimately the information for sort of the relatively simple supervised learning task here. You ultimately need the labels of, did this person sort of violate the conditions or not violate the conditions of pretrial release, because that's what these algorithms are predicting. So we winnowed it down quite a bit and developed the algorithm based on something around 6 to 8 of the key variables, really just looking at which ones were most predictive. And we wanted to match the specific sort of features of a defendant that we would also be showing in the narrative profile. So we matched which features were shown to the person in the narrative profile and which features were shown or were factored into how the risk assessment was making its predictions in the first place.
Okay, thank you. And what algorithm did you use to develop that risk assessment?
Yeah, so we used XGBoost models. We tried a couple that was the most definitely was the most effective at working through the data set. And the goal here, the development of the risk assessment was sort of an essential task for setting up the experiments well, but was not, we weren't doing anything particularly special with that. The goal was not to produce something that we could then say, this risk assessment is better or any number of those things compared to other ones. We were really just trying to go for something that was relatively useful and could generally align with the accuracy of some of those used in practice. So the goal was just to say, okay, what standard methodology can we find that would use this? So we tried a couple. XGBoost was pretty notably the most accurate. And so we were able to get a risk assessment that matched pretty well with some of the reported numbers on other risk assessment in terms of AUC and things like that. So so that was really the goal with that. And so, but yeah, there's always just a bit of the tuning process and playing with the different variables and finding the right model.
Correct. I'm going to go back to what you mentioned about how you measured the impact of this experiment. You mentioned that you tested 3 hypotheses. I mean, if I remember correctly, and for accuracy, reliability, and fairness. So my question is that how did you measure the impact of this risk assessment on the participants? I mean, the Amazon track participants. I mean, how did you measure that this is a reliable kind of, how did you measure the reliability? What indicator did you define? How did you, can you explain a little bit more about that?
Yeah, so a lot of that was taking advantage of the control and treatment group split that we had. And so it varies a little bit across the 3. The accuracy is sort of the most straightforward. Just looking at, we used a Breyer score for that. So looking at the Breyer accuracy or Breyer loss of the different predictions across the 3 different modes. For reliability, what we, and really for the fairness one as well, what we developed is a measure of the influence of the risk assessment, where we compared, where we were able to take, so if you think of the control group's predictions about a given defendant is the sort of the perception of risk about that person without the risk assessment. Then you have the risk assessment's prediction on the other hand, and then what you can take for the group that is shown the risk assessment, which is ultimately what we care about, you can measure the influence of the risk assessment by measuring where that person's prediction falls in relation to the control group's prediction and the risk assessment's prediction. So if I'm a participant in the treatment group and I'm evaluating a defendant, and my prediction about that defendant is exactly the same as the control group's average prediction about that defendant, that would suggest that the risk assessment is not actually affecting my predictions, because whether or not you're shown the algorithm, people are making the same prediction. On the other hand, if the treatment group predictions are, say that the control group's average prediction is 20%, the risk assessment says 40%. If the treatment group is saying then 30%, that would suggest that the influence of the risk assessment is sort of 50%. You can think of it as a weighted average. So that's really the question. When we're looking at the influence, that's really the question. We're looking at how do the predictions with the risk assessment compare with the same predictions about the same person without the risk assessment. And then that allows us to then look at both the reliability and the fairness by looking at those influence metrics compared to breaking it down in different ways.
Okay, so basically you compare the both score, I mean the prediction score between control and treatment, or comparing the impact of risk assessment, and then you kind of average it for one specific, let's say, defendant, you average it for all the participants, that the difference in the scores kind of as a measure for the influence, if I'm just trying to put it in the in the simplest word, I guess.
Mhm.
And yeah, thank you for that. And I guess we have a question from the audience. Let me go with the question. So the question is, do you know if the words with which the algorithm's predictions are presented to humans affect how humans interact with them? So for example, 70% likely to reoffend versus somewhat likely to reoffend versus at the risk of reoffending, or etc.
Mhm. Yeah, so the language that's used, we it's hard to know. I mean, that definitely, those types of things definitely do have an impact. One of the interesting things is that a lot of risk assessments, rather than so what we really focused on was presenting information in terms of statistical predictions. So we would present it as something like 30% risk and asking people to make predictions similarly.
Mm-hmm.
Which, although people definitely have different ways of, people are not always great about evaluating these numbers, at least it gives a firmer, sort of a firmer way of sort of a common grounding. A lot of risk assessments actually present their information in terms of broad categories such as low risk or high risk. And one of the problems with that is that it means that the people don't actually know what underlying probability that is referring to. And also you get I think there's going to be much more variability in terms of how someone is perceiving what is high risk, how different people might perceive what is high risk or what that actually refers to statistically. So that's one issue, where different ways of presenting it, although we didn't directly play with that, there's definitely those sorts of things can affect how people interact with it. We also looked a little bit at what happens if you present information, instead of saying 30% risk of reoffending, you can say 70% risk of not reoffending. So instead of sort of highlighting the negative thing, what happens if you highlight the positive outcome? And I would say that it's still a little bit inconclusive. I think some work has shown that sort of framing does actually have an impact and does meaningfully change people's predictions, or the decisions that people make. We experimented with that, did not find that it was changing the predictions that people make. But I think that's really something where you'd have to look at it in the context of decisions and not predictions, because highlighting the negative or the positive in terms of predictions, you're giving the same probabilistic measure. But in terms of just asking people to make a decision of releasing or detaining someone, how you frame the decision can potentially affect how you frame the information, and the likelihood it can affect how people make decisions. And so there is some work that has suggested that sort of negative or positive framing can definitely affect the decisions that people make. So all of these, and that's sort of what makes this so complex, is that it's not just a matter of how do we give, what is the prediction, but how we present that to someone and how that person interacts with it has a huge impact. And we had one measure in this study. One of the things we did was we looked at different ways of presenting information to participants. And when we compared just looking at the accuracy, when we compared the approach that had the lowest accuracy and the approach that led to the highest accuracy, just those changes in how the risk assessment was presented was equivalent to something like a 4% change in the actual accuracy of the risk assessment in the sort of like most simple condition where you'd present the algorithm. And so there's not necessarily an equivalence, but there's, just as much as we would think in a setting of how do we make sure the algorithm is fair and accurate, because the interactions matter, how we're presenting the risk assessment to people and how we're training people and all of that can have just as much impact on shaping how fair or accurate or any other sort of notion the actual final decisions or final predictions are. So those sorts of presentation effects are incredibly important for work to be studying.
Understood. Thank you. And just a follow-up question on that. So this experiment was performed on lay people with no expertise in this area. Do you think if the same experiment is going to be performed on not necessarily a group of judges, but let's say a group of legal students who have some background information, what do you expect the outcome be? Do you think it's just a guess. I know it might be very difficult to answer this question, but what do you think that might happen, might affect the results, the final results?
Mm-hmm.
Do you think you will see any difference, or do you still think that the impact of this risk assessment going to be kind of very explicit on the decision making?
Mm-hmm. So it's a little bit difficult to say, but I think that there is reason to think that the results would be broadly similar, not that any of the necessarily the sort of specific numbers would be exactly the right numbers and, sort of exact results. But I think broadly speaking, the patterns would likely be similar. And, some of the work on some of the empirical work looking at judges has found types of biases in how people respond to these categories or predictions of risk that are very similar to what I found in my work, and looking at how how judges respond differently to a black, will make different decisions for black or white defendants based on even those who are presented with the same category of risk, for instance. So that very closely aligns with what I found. And other work, not as much in this specific context, but other work has found that judges do exhibit many of the same cognitive biases as lay people do, and that the results that we find if we experiment with judges and experiment with lay people are not always so distinct. So that's not, that the alignment here between some of the early empirical work that's been done and this experimental work is encouraging then, in that sense of, okay, what we're able to find here at least has some overlap with what we are finding in the more limited empirical real world data that we're able to analyze, which further then suggests that the utility of taking this type of experimental approach. There's definitely going to be differences in terms of how people, how real civil servants like judges or in other context, welfare agents or teachers or whoever, they're going to have a different sense of identity and professionalism in responding to an algorithm. And certainly, some of the more detailed work on this has shown that in many cases, judges might be less willing to rely on an algorithm. They might be less trustful of it, might be less, have a sense that they know what they're doing and they have expertise already. So definitely you get some different types of interactions as they're bringing different senses of personal identity and professional identity into the interaction. But I think broadly speaking, we would expect the overall patterns to be relatively similar.
Mm-hmm. Thank you for the answer. So I have one more question perhaps before we end this presentation. So this experiment was specifically done for the risk assessment for the pre-trial cases. But as we all know that there's been so many use cases of these algorithms to assigning certain services to the citizens,
Mm-hmm.
or when its usage in the healthcare to getting certain medical care, to be eligible to get certain medical care or not. So how do you think how do you think having this algorithm kind of to augment the human decision making, or sometimes just be used as an automated decision making in certain system, can benefit from this research? How do you think this is for this specific context, or can we say that there might actually be a good reason to kind of to think that these algorithms might have the same impact in the context of healthcare, the same as it does in the court?
Mm-hmm. Yeah, so we looked at in the studies, although I didn't bring it up just because it's a lot to cover, we did also look at predictions and decisions in the context of financial services and whether or not to give out loans. So very similar structure of the sort of type of decision and the type of algorithm, but very different context. And what we found was a high level of overlap, where people in the first set of studies, pretty much the findings were pretty much identical, whether people were making predictions in the criminal justice context or the credit risk context. And in the last study, similarly found slightly different patterns, but overall the same type of effect of showing the risk assessment of changing how people are factoring risk into their decision-making processes. So, I think that there's the answer is going to be a little bit of both. And on the one hand, I think, we need to look at specific contexts, and we need to, look both in practice and experimentally in different contexts. And I think that's sort of the start of where we're at. This type of work is pretty new. And, I have done these experiments looking at 2 different contexts and found a lot of overlap, which would suggest that there can be more generalizable patterns. And it definitely aligns with a lot of the other research that people have done looking at how humans interact with algorithms. And increasingly more of this type of work is looking at different settings than even those that I was looking at. So I think, we're sort of at an early stage where there's definitely a need to look at a lot of different contexts. And then we can also then start to think about, okay, are these patterns, at least in broad terms, generalizable, so that we can start to think of a sort of more comprehensive science of human algorithm collaborations and decision making, and things that would translate across contexts, or even start to be able to say, these 3 contexts seem to have similar patterns, but these other 2 contexts are very different patterns. Why might that be the case? So we could maybe even start to get at more of a socio-technical contextual lens on what these patterns are, by also understanding the types of policy decisions that are being made, or maybe the types of the professionalization that people have. All of those things could also affect the interactions, because it's not just a technical system, and it's not just a technical system with an abstract human. It's, a technical system with a particular type of professional in a particular type of decision-making context. And so thinking about how all of those interact is really, I think, some of the more important next steps of where this work can go.
Mm-hmm. Thank you so much, Ben. I guess, we have one last question, which was basically you were addressing it in your last comments. So, and thank you everyone for joining us today. Make sure you sign up for our channel and our website and attend our future talks on AI ethics. And thanks again, Ben. We really enjoyed your talk, and have a very good day, everyone. Bye.
All right. Thanks, everyone. Bye.